Handling missing data. So one of the things back when we first started talking about pandas, where pandas is particularly strong and useful, it is in handling missing data. And so there are a couple of basic things that we can do here when we talk about handling missing data. There's masking, where we can use a Boolean mask to mask missing values. So I can identify them and through a masking operation. We use something called a sentinel value, where I want to use something like NaN, which is NaN, which stands for not a number, to keep those values. So if I want to have the values, if I want to keep the not a number, if I want to understand, if I want to use that information, as we'll see in our example, the NaN and the special value none object in Python are both useful choices. And so we looked at several different, we are going to look at several different functions for applying these. One is NA, in other words, is this not a number, is null, not NA, not null. So we can use these to detect whether a particular value or set of values contains not a number, or contains a null value. And then we can also use the drop NA function or the fill NA function to modify your data frame or modify the series, depending on whether you're using a series or a data frame, to either drop any of the null values or fill those with a different value. And so there are I have some examples here that I'm going to talk about, but I just want to mention that if you look in the Python Data Science Handbook in this page, let's see, what is it, data indexing selection, missing values, which is 3.04, they have a really nice discussion on how to deal with this, or what you do, how to deal with missing values, right? Because if you think about, there are two basic things we can do. We have two basic strategies and several different kind of sub-strategies. One is we can ignore missing values. Two is we can try to replace those missing values with, quote, a better value, right? And so what you choose to do is going to depend on the specific situation. And I just wanted to point out that this notebook in the Vanderplas book describes some of those basic trade-offs that you do and gives a couple of simple examples. For our part, for now, we're not going to focus too much on how to do that. We're just going to kind of demonstrate a couple of cases here. And so I'm going to demonstrate that with our data set. So if I look here at the data set df2, and so what I did was df2 was the one that I read in using the read CSV and then parse the dates. And so you can see that the month over here is my index, and so there's parsed as dates, and then I still have my 3 columns of economic news data, the unemployment rate, the jobs added, and the GDP, same as we saw before. But here I'm applying the isNull function, and the isNull function simply detects whether a value is null. And so you can see the return value. So the df2.isNull would have the true false values for 3 columns for all the data. And when I use the head 10 function, I basically said, just show me the top 10 rows, right? So if I didn't have the head 10, it would show me all of the data. I don't want to see all of it in my Jupyter notebook, so we just look at that top 10 values, and you can see that the isNull applies to my GDP column, right? So I have GDP. If I look at unemployment rate, they're all false for isNull, so they're not null. I look at jobs added, they're all false for isNull, so none of them are null. But GDP is false, true, true, false, true, true, false, true, true. So I have this repeating pattern of saying, okay, well, this one has a value, then I have 2 no values, then I have a value, then I have 2 no values. And the reason that is for this particular data is because GDP data is reported quarterly rather than monthly. And so this is monthly economic data. And so this is the first quarter report, the second quarter report, the third quarter report, and the fourth quarter report. Okay, and so it's not that those values are missing per se, because there just aren't any values, right? So they're not in my data frame, but it's not that someone forgot to enter the data. It's that the data don't exist because they're on a different reporting schedule. And so if we want to do some analysis on that data set, let's say that, for example, we wanted to use Numpy. So here what I did was I just extracted the GDP data. So remember that df2.gdp is going to return to me a pandas series. And then I just converted it to a Numpy array. And I did that just so we can demonstrate this and use the Numpy mean function. So when I execute that, I get NaN. So what does that mean? So I'm trying to find the mean of a set of values, and it returns to me NaN. What's going on? Why would it return to me NaN? Why would it return to me NaN, which again stands for not a number?
Because it contains some known values.
Yeah. So when we pull out the series, we're getting all of these values, and then we convert it to a Numpy array. So in essence, what I'm going to have is a Numpy array with that first quarter GDP, then a not a number, in the second quarter GDP, and a not a number, in the third quarter GDP. So I'm getting the GDP, all of the GDP values, but thrown in, I have a whole bunch of null values. And so when I tell Numpy, okay, apply the mean, it doesn't know what to do, right? Because it's saying, well, it's not clear to me what you want to do. So it just bails and says, not a number, okay? And so I mentioned here that that Numpy doesn't handle it well, and then I have my well in quotes, and my question then is, well, why is my well in quotes? What do I mean when I say doesn't handle it, quote, well? Well, what I mean there is, well, you have to define what should happen. Okay, so what do you want to happen is when you have null values, do you want it to ignore them? Do you want it to warn you? Do you want it to replace those values with something like the median or the mean or something else? So the reason that I have well in quotes is because, well, good or the quality, the wellness is undefined. Okay, and so you can't just say, does it handle it well or not well? You have to be more explicit about how you want to handle it. Note that I can remove the NA values. So if I just do drop NA, right? So we did before, we did at the top, we did is null. And I can use the drop NA function, and it says, okay, we'll just drop the null values. So the first thing to note that it does is all of the null values are gone, but there's a lot of good information that's gone too, because the unemployment rates were reported monthly. The jobs added are reported monthly, but every 2 out of every 3 have been removed, because the drop NA function by default, when you apply it to a data frame, drops rows, entire rows, whenever a row contains an NA value. And so I can use that and say, okay, well, let's just apply the Numpy function now, the Numpy mean function. And so when I do the drop NA, so recall in here that what I'm doing is I'm doing df2 drop NA, and so this returns a data frame with the NA values removed. And then I'm doing the column selection process here by saying, give me the GDP column. And so inside here, I am getting a data series that has no NA values. Then I'm converting it to a Numpy array and then applying that in p-mean that we saw before. And of course, it now computes it. So if what we want to do is ignore the null values, we can use this approach where we just do the drop NA from the values that we want. We can also just use the Pandas series directly. And so here, what I do is I just extract the GDP from the df2 directly, and then I compute the mean. And so this has the NA functions. And so the Pandas function by default ignores the null values. And so you can see that when you compare the results that we got from the Numpy mean from the data frame where we dropped the NA values with the Pandas one where we kept the NA values. You can see that we got the exact same values. And of course, we can apply that across the data frame. So exactly the question that was asked at the beginning of class, if I want to get the mean value on df2, I get the unemployment rate, the jobs added, the GDP, right? So these are the numerical values where it applied the mean function. Note that what we don't have is the index, right? So the question would be, well, what happens if? Yeah.
Can you go up really quick? I'm trying to figure out about the NP array.
Okay.
That one.
Which one are you trying to figure out?
16.
You're trying to figure out what this one does, or what?
I'm trying to figure out why it's not working for mine. Well, I guess this is what exactly you did.
Well, I didn't, other than execute it, I didn't type it in here. So if you got it off the, if you grabbed it off the GitHub, it should work because I didn't change anything.
Did you import NumPy?
Excuse me?
Asking if he imported NumPy already.
Oh, I'm sorry. Yeah. Did you execute at the very top of the page where you did import Numpy as MP, if it give you an error?
No, I did all that.
So what is it saying? When you say it doesn't work, what does it mean?
Hold on, I gotta go back down. I'm gonna make sure I did the ball. Pretty sure I did because I was following along. So it basically says X equals Numpy array quotations df2.gdp.
So you don't have quotation around the df2, by the way. The quotation's only around GDP.
Oh, and mine also says GDP, not drop in name.
Yeah, so yeah, if you can't tell me exactly what the error is, I'm not sure I can help. So you don't have this exact same line? You don't have this exact same thing?
No.
What does yours say? I mean, did you, again, Omar, did you type this or did you get it from GitHub?
I got it off GitHub. It was just in Jupyter. It was just different from yours.
Yeah, so maybe hang around after class or come to office hours because if I can't see it, I can't tell you what the error is. I'm happy to explain what's going on with this one, and then maybe you can back into yours and figure out what's going on. Because as I said multiple times, we do this. There's a lot of stuff going on in this one expression. And to understand exactly what's going on, the thing you want to do is go, as I've said, inside out, left to right. So inside out basically says, let's jump in here in these parents and say, what's going on in here? And so we start out with df2. And so df2 is read the data frame at the top where I use the date column as the index. So that's what df2 is. And then I apply to df2 the drop NA. And so what that does is drop the corresponding rows with the NA value. And so that's exactly what we see right here, df2 drop NA. And so you can see that every 2 out of every 3 months are dropped. So I have 1, 1, I don't have 2, 1, I don't have 3, 1 because they didn't have GDP values. I don't have 5, 1, I don't have 6, 1, again, no GDP values. So this drop NA gave me a data frame that is indexed by date, has 3 numerical values and no NAs. That's what happens on this internal right here. Then I said, let's pull off the GDP column. And so pulling off, oops, I didn't mean to do that. Pulling off the GDP column is going to create a series that has just this column with this index. That's what I then apply or converted to a Numpy array, X, and then did the mean of X. And so one thing that you could look at is you say, well, what is X? So when you run X, do you get something that looks like this? Where I just said, okay, well, this is my Numpy array that has no NA values.
Okay. I got it now. I changed myself to look like yours.
Okay. Yeah, go ahead. Go ahead.
Okay, so I think I have a quick question about the NA and NaN. So what's the difference? So the NA means the empty value, right?
Right.
It's gone. And also what is NaN?
So NaN is a floating is what's called a sentinel value. So if you have a floating point, well, what exactly is not a number and a floating point? So it's a special data type that represents, for a floating point number, the lack of a number. So again, it's what's called a sentinel value.
Okay. So it means there is some NA value in the data frame, right?
Yeah, it means there's NA values in the data frame because you can see in here, if I just look at df2. So here, can you see if I look at df2 and I just pulled off 1 year, right? I pulled off 2012 and you can see NaN, 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 NaN. Because as I said, the GDP is only reported monthly. So when Pandas read this data from the data file, there were no values to read.
Yeah.
And so it had to represent the fact that there are no data values. And so there are two basic ways to represent the lack of a data value. There's the Python data type none, which we've seen before. And then there's NaN, which is the sentinel value for floating point numbers that have that same basic intent where you don't have a value. And so when I did drop NA, it went in and said, okay, let's drop these two rows, let's drop these two rows, let's drop these two rows, let's drop these two rows. And so it just drops all of those values rows where I have that NA value. And this is what the resulting data frame is.
So we use the NaN represent the NA value, right?
Yes.
Okay, good.
Or none. You can use none or NaN.
Okay.
Okay. And then I was going to do the same thing about the non-numeric column. So remember when we read in data frame 1, we just had the string values for the dates. And so we created an implicit index when we did df1 back at the very top. So when I apply the mean function across the data frame, you can see that it ignored the non-numeric columns. And so then I just said, well, why did we do that? Or why does it do that? Well, there's a parameter called numeric only, and the default value of numeric only is true. So if I say, well, numeric only equal false, it's going to try to apply the mean function to the non-numeric values. Well, that's going to cause an error, as you see right here, is it's causing an error basically saying, I don't know how to deal with this because you've told me to compute the mean on the non-numeric columns. You have these objects, which are strings. I don't know what to do, and so that's why we get this error. And then I gave you the reference here to see that in the help. Now, my comment here, I'm not sure why we'd want to do it, right? So again, you're just going to get this error. But it is an option if for whatever reason you want to apply it, that function or other functions that fall into the same category to the non-numeric data, there's a mechanism to do it. In this case, it doesn't do anything for me and it just causes an error, but it is doable. Okay, any other questions for me on handling missing data? As I mentioned before, this is particularly a strength of Pandas, is allowing it to process missing data. And when you deal with large data sets, again, you often have missing data. And so in the example that I just did, there's a reason we have missing data because the data didn't exist, right? So the GDP is only reported monthly. But in a lot of cases, you just don't have a value. So I might have a data set and someone didn't record the value or someone miscoded the data value. Right? So there are multiple reasons why we might end up with not what are called pristine data sets where all the values are there and they're all perfect. And so Pandas and tools like it, as we'll see when we get into R, also has pretty strong features for dealing with those types of situations where I either have missing data or miscoded data or things like that. Okay, so I want to mention, but we're not going to talk about hierarchical indexing. So I'm just going to mention it and describe it and make the note that Vanderplas has an entire notebook on how to do this. And so the only reason I'm mentioning it, we're not going to use it in our class, but I mention it because it's pretty useful if you have a data situation where you need to apply it. And so the situation that you can see here that they have listed as the bad way is if you want to look at our state data that we saw and look at the population values, but I want to have multiple population values, right? So maybe I want to track whether a state is growing in population or declining in population or staying the same in population. And so what we have here is we have the population of California in 2000 and 2010, the population of New York, 2000, 2010, Texas, 2000 and 2010, right? And so I want to build a data frame where I have all of these, this information. And so the bad way here that he has listed is I can do it, right? Because an index, right? I can use different data types for an index. And so what we've done here is we've just used tuples. So rather than having an integer index or a string index or a date index, all of which we've seen, I'm going to use a tuple and say I have index value of California 2000, and that's exactly what you see right here. California 2010, New York 2000, New York 2010. And so these are different index values, and I can then access my information using these different index values. So I could access all of my California data through index searching. And so the better way to do something like this, where what we actually have is hierarchical data, is by using Pandas hierarchical indexing functions built in. So what the hierarchical index is something called a multi-index. As I said, I'm just pointing it out here, and we're not going to use these in any of the examples that we do. But I just want to point out the existence that now we have the index is at multiple levels. So I have California. So if I look at the highest level of indexing, I have what we saw before, California, New York, Texas. And then I have within each one of those indices, I have sub-indices. So I have 2000, 2010, 2000, 2010. And when you look in the van der Plas notebook, you will see that having this type of structure, it's a lot easier to parse the data, to do any kind of aggregation, to do comparisons across states and so on, as opposed to using the tuple structure for the index values. Okay. So that I just took these screenshots from that notebook, and so all of this is in there. The code examples are in there. So certainly, if you have a situation where you have this type of hierarchical data, have a look at how to use the multi-index, and I think you'll find it quite useful. But we're not going to apply it here in our class.